Welcome to the NIOS studio. This is Dr. Devika R, Assistant Professor, NSS Training College, Ottapalam, giving a lecture on the topic factors and multiples. To begin with, we will see the objectives for this session. Determination of HCF. HCF means highest common factor. The second objective to be dealt here is the determination of common factors and multiples. Number 3, least common multiple, which is abbreviated as LCM. And the final one, how to use HCF and LCM in solving real life problem. Points to remember. Before dealing with the topic, we need to remember few points which will be helpful in learning the topic factors and multiples. As we all know, 1 is a factor of every number. If we take each and every number starting from 1, we can see that 1 is a factor of every number. Number 2, every number is a factor of itself. 3, every factor is less than or equal to the given number. Final point, number of factors of a given number are finite. So, these 4 points should be remembered before dealing with the new concept factors and multiples. Now, we will see how to determine the factors of a given number. For example, I am taking 2 numbers, say 15 and for the second example 24. Now, how to find the factors of 15? As I have said just before, 1 is a factor of every number. So, the first factor of 15 is 1. The second factor is 3. This is because the number 3 exactly divides the number 15. And the third factor is 5. 5 is a factor of 15 because the number 5 exactly divides 15 and we get a remainder 0. Thus, 1, 3 and 5 are the factors of 15. Second question, find the factors of 24. 1 is a factor of every number. So, the first factor of 24 is 1 itself. The other factors are 2, 3, 4, 6 and 24. These are factors because the number 2, 3, 4 and 6 exactly divides the number 24 and we get a remainder 0. And the final one, every number is a factor of itself. Thus, we have got 6 factors here and as I have said just before, the factors of a given number are finite, which means we are able to count the factors of a given number. Common factors. You would have noted the word common, that is prefixed with factors. So, how to determine the common factors is the next thing to learn. Now, how to determine the common factors? Step 1, write down the factors of each number. As we have just studied, write down the factors of the given number. Second one, determine the factors that are common to both the given numbers. So, in such cases, you will be given 2 numbers. Now, write down the factor for each number and then determine the factor that comes common to both number. Let us explain using an example. Find the factors of 10 and 15. So, step number 1, write down the factors of 10, write down the factors of 15. Step number 2, determine the factors that are common to both 10 and 15, and that will be the common factors of 10 and 15. So, the factors of 10 are 1, 2, 5 and 10. 1 is a factor of every number. 2 and 5 exactly divides 10, and every number is a factor of itself. Thus, we get 4 factors for the number 10. Now, the factors of 15. 1 is a factor of every number. Every number is a factor of itself. For this, 15 is a factor, and the numbers 3 and 5 exactly divides 15. Thus, we get 4 factors for 15. Now, find out the factors that are common to both 10 and 15. We can see that the number 1 and the number 5 are common to both 10 and 15. Thus, we can write the common factors of 10 and 15 as 1 and 5. Example 2. Find the factors of 4 and 18. As done before, write down the factors of each number. Step number 2, determine the common factor for both the numbers, and that will be the common factor of 4 and 18. The factors of 4 are determined as 1, 2 and 4. Factors of 18 are 1, 2, 3, 6, 9 and 18, because 2, 3, 6 and 9 exactly divides the number 18. Now, which are the common factors of 4 and 18? We can see that the number 1 and 2 are common to both 4 and 18. Thus, the common factors are 1 and 2. Thus, if we are able to determine the common factor of given numbers, the next task is to determine the highest common factor. So, here we have got 2 terms prefixed with the word factor, highest and common. Highest common factor in mathematics is abbreviated as HCF. In HCF, H denotes highest, C denotes common, and F stands for the phrase factor. HCF of 2 or more numbers is the highest or the greatest of their common factors. So, we have got one more thing to do. Find out the factor that is highest or greatest to the common factors, and this will help in the determination of highest common factor. Method 1. There are different methods to determine HCF. Step 1. Find out the common factors. It's simple thing to do because finding the common factors. Step number 1. Find out the common factors. We have just now learned how to determine the common factors of numbers. Step number 2. Determine the highest or the greatest among the common factors. Example 1. We will see how to determine the highest common factor for 2 given numbers. I am taking for example 2 numbers 10 and 15. So, what we have to do here is step number 1, write down the factors. Step number 2, find out the common factors. And step number 3, determine the greatest number among the common factors. Factors of 10 are 1, 2, 5 and 10. Factors of 15 are 1, 3, 5 and 15. So, which are the common factors? We can see that 1 and 5 is common to both 10 and 15. Now, the next task, which is the greatest number among the common factors? We can easily see that 5 is the greatest number among these common factors. Hence, HCF or the highest common factor equals 5. Let's look at one more example. Find the HCF of 20, 28 and 36. In this case also, we have to determine the factor for each number first. Second step, determine the common factors. And the final step, determine the greatest number among the common factors. The factors of 20 are 1, 2, 4, 5, 10 and 20. Factors of 28 are 1, 2, 4, 7, 14, 28. Factors of 36 are 1, 2, 3, 4, 6, 9, 12 and 36. So, the first step is complete. We have determined the factors for all the three numbers. So, the second task or the second step, determine the common factors. By observation, we can see that 1, 2 and 4 are common to both the numbers. Now, the final task before us, determine the greatest number among the common factors. We can easily see that 4 is that number which is greatest among the common factors, and hence highest common factor equals 4. Now, the second method for the determination of HCF is called prime factorization method. Here, please observe the words prime and factorization. You would have learned in the previous classes what is a prime number and what is a composite number. This particular concept that you have learned before is used here in order to determine the HCF in the second way. So, let us see first what is factorization. When a number is expressed as a product of its factors, it is called factorization. Example, we can see that the number 24 can be expressed as the product of 3 and 8. 3 and 8 are the factors of number 24. So, whenever we are able to represent a number using the product of its factors, it is called factorization. Thus, we can write 24 as 3 into 8, and this is how the number 24 has been factorized. Now, let us see other factors of 24 and how we can express 24 in the prime factorization method. 24 can be written as 2 into 12. 24 can also be written as 2 into 2 into 6, and it can also be expressed as 24 equals 2 into 2 into 2 into 3. In all these cases, the product of factors equals 24. Now, another way in which 24 can be factorized is shown below. 24 can be expressed as the product of 4 and 6. That is why 24 is written as 4 into 6. 24 can also be expressed as 2 into 2 into 6. The same can be expressed as 2 into 2 into 2 into 3. Now, let us see how 24 is categorized in another way. 24 equals 3 into 8. 24 can also be expressed as 3 into 2 into 2 into 2. It can also be expressed as 2 into 2 into 2 into 3. So, these are the three groupings by which the number 24 can be factorized. Now, how do we link this with the prime number? From the above factorizations, we arrive at only one factorization. That is, we are taking into account only this factorization. 24 equals 2 into 2 into 2 into 3. I am not taking any of the rest factorization for one particular reason. What will be the peculiarity of this factorization? Are you able to find something peculiar about this factorization? This is the only factorization in which the factors are prime numbers. See, the number 2 and number 3 are called prime numbers. In this, the only factors which are prime are taken here. That is why this method is called prime factorization method. Thus, in prime factorization method, prime numbers which comes as factors are multiplied in order to get the given number. Let us check for another number 36. 36 can be expressed as the product of factors. 2 and 18 are the factors of 36. Hence, 36 equals 2 into 18. 36 can also be expressed as 2 into 2 into 9 because I have replaced the number 18 with 2 into 9. Now, for the third expression, again I am splitting the number 9 as 3 into 3, and that is why the third expression 36 equals 2 into 2 into 3 into 3. In all these cases, the product of their factors equals 36. Now, moving on to the second grouping of 36. 36 can be written as 3 into 12. 36 can also be expressed as 3 into 3 into 4 because when 3 and 4 is multiplied, we get 12. Now, another way to express 36 as the product of its factors is 36 equals 3 into 3 into 2 into 2. This is because I have used 2 into 2 instead of the number 4. Now, rearranging the third expression, I get 36 equals 2 into 2 into 3 into 3. Now, another expression for 36 is when 4 and 9 is multiplied, we get 36. Therefore, 36 equals 4 into 9. Now, 4 can be split up as 2 into 2, and hence the second expression is 36 equals 2 into 2 into 9. Now, again in the third expression, I have split 9 as 3 into 3. Thus, 36 equals 2 into 2 into 3 into 3. Now, moving on with the next categorization of 36 can be expressed as the product of its factor 6. 36 equals 6 into 6. Now, 6 can be written as 2 into 3, and hence 36 equals 2 into 3 into 6. Now, for the third expression, I am again splitting 6 as the product of 3 and 2. Thus, 36 equals 2 into 3 into 3 into 2. Now, rearranging the third expression, 36 can be expressed as 2 into 2 into 3 into 3. Now, which among the categorization becomes the prime factorization of 36? As I have said just before, the product of the factors, and that too the factors should be prime number. Only those numbers are selected while determining the prime factorization method, and hence among the above determined expressions for 36, 2 into 2 into 3 into 3 is the right answer for the prime factorization of 36. Please note that the number 2 and 3 are the only factors which are prime in this example. HCF using prime factorization method. Steps for determining HCF using the prime factorization method are: step number 1, express each given number as the product of its factors. Step number 2, express each factor in an exponential form. And step number 3, HCF is the product of the lowest powers of each of the prime factors that commonly occurs in both the numbers. Hence, in this case, we should express each prime factor in an exponential form, and that exponential form will be used for determining the HCF of numbers. Let's find out HCF of numbers using the prime factorization method. Find the HCF of 12 and 18. As said just now, 12 can be expressed as 2 into 2 into 3. Now, as I have just commented, the number should be expressed in exponential form. Thus, 2 into 2 can be grouped and it can be written as 2 raised to 2, or we can say 2 square. 3, the factor which comes only 1, can be exponentially expressed as 3 raised to 1. Thus, 12, which is equal to 2 into 2 into 3, when expressed in an exponential form, becomes 2 raised to 2 into 3 raised to 1. Similarly, 18 can be expressed as 18 is equal to 2 into 3 into 3 equals 2 raised to 1 into 3 raised to 2. This is because 2 occurs only once and the factor 3 occurs twice. As we know, HCF is a product of the lowest powers of each of the prime factors that commonly occurs in both the numbers. So, find out the lowest power for each number. For the number 2, the lowest power is 2 raised to 1, and for the number 3, the lowest power is 3 raised to 1. Hence, we choose 2 raised to 1 into 3 raised to 1 for determining HCF. Thus, HCF equals 2 into 3 equals 6. Now, there is a third method for determining the HCF, or the highest common factor. This method is called the long division method. Here, the method of division is employed to determine the HCF. Few steps are to be followed here. Step number 1, we will be given two numbers and the larger of the two numbers is divided by the smaller number and the remainder is determined. Step number 2, while dividing here, the divisor of the previous division is taken as the dividend and it is divided by the remainder of the previous divisions. And this method continues till the remainder becomes 0. That is why we use the term long division here. We do a lengthy division in order to determine the highest common factor. Divisor of the last division where the remainder is 0 becomes the HCF. So, by the end of the division, we need to determine that divisor in which the remainder becomes 0 as the HCF. Let us look at one example to determine the highest common factor using the long division method. Find the HCF of 12 and 18. The greater number in this group is 18. Hence, the number 18 becomes the dividend and the other number 12 becomes the divisor. Now, we have to divide 18 by 12. When we divide 18 by 12, we get the quotient 1 and remainder 6. In the next step, the divisor in the first case becomes the dividend for the second division, and hence 12 becomes the dividend and the remainder 6 becomes the divisor. And when 12 is divided by 6, we get the quotient as 2 and the remainder as 0. Thus, the divisor of the second division becomes the highest common factor and it equals 6. Application of HCF. Now, how to apply the HCF in real life situations? Let us look at one example. There are 24 boys and 30 girls in a class, and separate lines should be formed for boys and girls with equal number of students in each line. What should be the greatest number of boys or girls with which the lines are to be made so that all the boys and the girls are accommodated? So, solution here is that determine the number of boys and girls. Number of boys equals 24 and number of girls equals 30. We are asked to find out the greatest number of boys or girls, which means we need to determine the HCF. As explained just now, any of the three methods can be used to determine HCF. Let's proceed with the prime factorization method. 24 can be expressed as 2 into 2 into 3, and when written in exponential form it becomes 2 raised to 3 into 3 raised to 1. 30 can be expressed as 2 into 3 into 5 equals 2 raised to 1 into 3 raised to 1 into 5 raised to 1, and thus HCF equals 2 raised to 1 into 3 raised to 1 equals 6. Common multiples and LCM. LCM is the short form for lowest common multiple. Here also we need to remember a few things. Every multiple of a number is greater than or equal to that number. The number of multiples of a given number are infinite. Every number is a multiple of itself, and the multiple of a number will be divided by itself. Determining the common multiples. For this, let's begin with an example. Find the multiples of 8. Multiples of 8 will be a number that is divisible by 8, as you all know. Therefore, multiples of 8 are 8 into 1, 8 into 2, 8 into 3, 8 into 4, 8 into 5, and so on. Therefore, the multiples of 8 are 8, 16, 24, 32, 40, etc. Finding LCM. There are also different methods to determine the LCM. The method 1 is that if two numbers are given, steps are as follows. Step 1, write down the multiples of the given numbers. Step 2, find the lowest common multiple for both the numbers. Example, find the LCM of 8 and 12. The solution is determine the multiples of 8 and 12. Multiples of 8 are 8, 16, 24, 32, 40. Multiples of 12 are, when we write 12 into 1 it becomes 12, 12 into 2 it becomes 24, 12 into 3 it becomes 36, 12 into 4 becomes 48, and so on. It goes infinitely. Thus, LCM is equal to 24. Finding LCM in the second method, it is called prime factorization method. The steps here are: step number 1, write down each number as a product of prime factors, as how we did in HCF. Step number 2, LCM is the product of the maximum number of each prime factor that occurs in either of the numbers. Let's do it with the help of an example. Find the LCM of 12 and 18. Solution: 12 can be written exponentially as 2 square into 3 raised to 1, which means it is 12. Now 18 equals 2 raised to 1 into 3 raised to 2, and LCM equals 2 raised to 2 into 3 raised to 2 equals 2 raised to 2 means 4 and 3 raised to 2 means 9. Thus 4 into 9 equals 36. HCF and LCM. There is a relation between HCF and LCM, and it will be interesting to find out what the relation between HCF and LCM. Let us use the above mentioned examples. I am putting all the numbers in a tabular form. The first column is numbers, second is product of numbers, third column is HCF, the fourth column is LCM, and then the product of HCF and LCM. The first example, 12 and 18, if we take the product of numbers, we get 216, HCF is 6, LCM is 36, and the product of HCF and LCM is 216. For the second example, 16 and 28, when we find the product of numbers, 16 into 28, we get 448, and HCF will be equal to 4, LCM equals 112, and the product of HCF and LCM is 4 into 112, 448. For the third example, I am using the numbers 25 and 35. When we multiply it, we get 875. HCF will be equal to 5. When LCM is determined, we get 175. And when we multiply HCF and LCM is 875. So what can we conclude from the above examples? It is interesting to note that the product of two positive numbers equals product of their HCF and LCM. Let us rewind the whole concepts we have learned here. HCF of two or more given numbers is the highest or the greatest of our common factors. HCF is the product of the lowest powers of each of the prime factors that commonly occurs in both the numbers. HCF can be determined in three different ways. As discussed in this session, LCM is a product of maximum number of each prime factor that occurs in either of the numbers. LCM can also be determined in two different ways. And finally, product of two positive numbers equals product of their HCF and LCM. Hope you have understood the concept of factors and multiples. Thank you for your patient listening. Thank you.